This part 2 of the video shows what we're calling the release from the rear method, which is kind of similar in logic to the insulated rail method, which was covered in the previous video 667. And our method here is we wire the stop block to the normally open terminal of the Z-stuff relay. And the logic is that when the front train gets up to the dead stop block, it stops and it has to wait for a train coming up from the rear to release it. When the train in the rear crosses in front of the detector, which will place back in the rear, that'll close the relay and put power into the stop block, which will allow the train to leave the stop block. Again, similar to how the insulated rail method works. When a train comes up the rear and crosses over the insulated rail, it sends power up front of the stop block. And as mentioned, we think this is less versatile than the delay from the front method as demonstrated in part 1. However, it might work better if we had a really long loop and we want the train approaching the block to start the stop train at the station. Say if we wanted the front train to stay in the station most of the time and have the train coming up from the rear stop it, and this was a really long loop, it might be easier to use this type of logic, because with the time delay only goes up to 1 minute in the stock DZ-1012. So say you had a loop that took 2 minutes to get around, this method would be easier to control the two trains. Now, important note, keep in mind we're using a DZ-1011 block signal detector for this video demonstration. The DZ-1011 is an older model that only has a 1 second fixed time delay, and it'll work for this part 2, but it won't work for part 1. So we recommend using a DZ-1012, whichever method you try. But if you happen to have a DZ-1011 handy, you can use it to try out this part 2 type of method. And again, the last section of this part 2 of the video, there's some related videos shown parts of them that just give you an idea of other ways to do this control of two trains. Again, thanks for watching. Here we are with two trains on the track. Now we'll start this system up. You see that black train is in the stop block, and it'll wait there until the yellow train comes around and crosses in front of the sensor, at which point the block will be powered up and the black train can leave. Now you can see the sensor went back to green, which means the stop block is dead again. So now you can see the yellow train got stopped in the stop block, and that train will wait there until the black train comes around in front of the sensor. The overall logic is you have one train stopped in the stop block, and it sits there and waits there until the other train travels around the layout and comes in kind of behind it, crosses in front of the center, which energizes the stop block and allows the stop train to start up and leave. And we can't put that sensor too much closer to the stop block than it is now, or the block might be still turned on when the second train comes into it. We want to make sure that the stop block is turned off before the second train gets there. In other words, where that black engine coming around, that came past the sensor and it went back to green, which means the block is off. We may have to make sure that happens before that train gets into the stop block. And as I mentioned, this is kind of similar in logic to the insulated rail system, except here we're using the Z-stuff DZ-1011 block signal instead of an insulated rail. And the advantage of that is we don't have to construct an insulated rail. It makes the construction a little bit simpler. Plus we can move the sensor around. Whereas if you build an insulated rail system for detection, it's a little harder to move it. Plus it's more work to build it. disadvantage of this system is you have to wire up a few more wires to hook up the Z stuff detector to the Z stuff relay. And each train has to be long enough to hold that sensor closed. I should say that each train has to be long enough to block the sensor long enough that it keeps that relay closed so the train in the stop block can get started up. So this system kind of has some of the same constraints as an insulated rail system. You need, it works best with two trains approximately the same length, running approximately the same speed. Now we've moved the detector back. It's over on the left there, about a couple of feet in front of that black engine on the left, and it'll have an effect on the operation. The trains will tend to be running more of the time. We're just about at the limit of how far we can be, because the black engine, that's got to be in the stop block stopped before that yellow engine gets to the detector. If the train hasn't reached the stop block yet, it'll miss its chance to get out of the stop block, so to speak, and the second train will come along and rear end it. You can see that yellow one is just barely making it into the stop block, just getting stopped, and the black one reaches the detector. The black train is running a little faster than the yellow train, so the black train is the critical one here. But this system's right on its limit as you see it, but you can just see the different effects you get when you move the detector to a different position. Like I say, with the detector as far back as it can be, which is the situation we have now, it keeps the trains in operation as much as possible. If you move the detector forward towards a stop block, like in the previous video clip, then it tends to keep one train stopped most of the time while the other train is out on the main line. Now, if these engines were more different in speed than what they are, we'd have to move that detector back closer to the stop block, because we always got to make sure that the slowest engine has reached the stop block before the faster one reaches the detector, so it doesn't miss its chance to get started out of the stop block. We've got a Z-Stuff DZ-1100 block signal detector hooked up to a Z-Stuff DZ-1008 relay, so that when this block signal is activated, it closes the points on the relay. The relay is wired up in its normally open position, but when we push this car in front of the detector, it'll block the detector, and the detector will detect it and change to red, and it'll close the normally open points to closed. Now that relay is hooked up to this block, which is over here. This is a loop, a track. It's just a continuous folded loop, and it comes around here and into this block, which is denoted by the two red note cards which denote the beginning and end of the block. Right here is right there is a gap in the center rail cut here, and there's a gap in the center rail cut here. So again, the two note cards denote the beginning and end of the block, and this will allow us to do two-train operation in a manner somewhat similar in logic to the insulated rail. Now this lighted passenger coach on the right is sitting in the block, so the detector is not activated, so the block is turned off. When we push this car into the detector, you can see it turns the lights in the passenger car on, because it switched the relay from its normally open position to normally closed. Now if we remove this car in about a second, the the detector times out. It has a 1 second delay from whenever the last car passes in front of it to when it switches back to green. So again, just to repeat that, you see the signal goes from red to green and the lights come on in the passenger car. If we clear the detector, it goes from red back to green and the lights go off in the passenger car, which means the power is off in this stop block. Here's figure 3, which we call method 2, release from the rear, which we're using for the part 2 of the video. And in this case, the relay is normally open instead of being normally closed like it was in part 1. And we use the DZ-1011 for this part 2 of the video. And it does work. If you have neither of these, I would purchase a DZ-1012V. It's a little more expensive, but it's more capability. It'll do everything the DZ-1011 will do. This is limited in that it does not have an adjustable time delay. The time delay is fixed at 1 second, so you can't use this one for method 1, but it will work for method 2, and that's what I showed being used in the video. Now here's the schematic from before that shows the hookup of the block detector to the relay. And again, as before, over here we've got a terminal block in the drawing, and this system kind of simulates what they call the insulated rail method. The insulated rail method was discussed back in the previous video 667, but how that works is if this was insulated rail, it's not, but you'd have, if it was an insulated rail system, you'd have an insulated outer rail here. And when this train came along and it crossed the insulated rail with the one that had power, it would send power over to the stop block, and this train would leave. Now, with what we're showing in this video, we don't have the insulated rail. We're using the block detector in place of the insulated rail. And this saves us from constructing an insulated rail. Plus, we have the flexibility of moving the detector around. It's a lot more cumbersome to move the insulated rail block around the layout. It's much easier to move the detector, I believe. And we don't have to build the detector, and we don't have to cut any blocks over here. So, and the only disadvantage is we have to wire this thing up and we have to buy a detector. Whereas with an insulated rail, you don't really have to buy anything. You just run you just cut gaps in the outer rail and run it over to the stop block. But going back to the terminal here, this is the actual wiring. And one more thing on the logic of this, one disadvantage, I think the method 1 is shown in the first video, part 1, is probably the one most people might want to use if they do this. The disadvantage of this is that for one train operation, you have to put a jumper between the main line and the stop block, because if this engine isn't in the picture, you're just trying to run the one train, it's going to come around and stop in the stop block because the relay will be normally open, and it's not going to go anywhere. It's going to be waiting for the second train to release it. And if you have one train, that second train's not on the line. But how this works with two trains, I better explain that. How this works with two trains, when this train is stopped over here and this blue train is coming along, when it passes the detector, and we've got the relay wired to the normally closed contact here. Excuse me, we got it wired to the normally open contact. So when the train comes past the detector, the block signal will change from green to red as before, but because we've wired up to the normally open contact, the relay will send power down to the block. When the block's in the green state, the power's trying to go out the gray wire, which is not connected to anything, so the block is dead. So this train has to wait here for a train to come along and change the block from green to red, which changes the relay from the normally closed to the normally open contact position, which will send power down this wire to the stop block and release this train. Going back to this right side of the drawing, figure 3B, that shows a terminal block, everything for this part 2 of the video, this method 2 that we're showing, is the same as part 1 of the video as far as the wiring, except this one wire to the stop block now connects to the normally open terminal instead of connecting to the normally closed wire like it did in part 1. That's the only difference in the wiring. So if this was a DZ-1011V detector, you could change it back and forth to operate like method 1 or method 2 just by moving a single wire from the white wire to the gray wire and back and forth. Now we're at the end of the demonstration of this block signal detector method. This section 2B is a related videos section. It shows snippets of some videos that show alternate methods of two-train control. And the links to all these videos, should you choose to watch them, they're down in the bottom in the text description. Now that's assuming you're watching this on a computer. It seems like if you watch this on a phone, all that information gets dumped. But if you're on a computer, all these links should be down in the bottom in the text description. Here's the previous video, 667, where we took a look at Talley Ober's system that controls 3 trains using the insulated rail method. You can see there's a stop block here and another second stop block over here. So with those 2 stop blocks, he automatically controls these 3 trains on this system. Here's a drawing for that same video, 667. We have a stop block here, and we have a second stop block over here, and this control block takes care of this stop block, and this control block 2 takes care of this stop block 2. And as we mentioned, this is similar to what we call in this current video for the Z-stuff detectors. This insulated rail system is kind of similar to what we call release from the rear. In this case, you have a stopped engine, and it depends on a second train coming along up behind it to release it. In other words, when this engine goes in the control block, it releases this engine from the stop block, and likewise, when this engine goes into the control block, it releases this engine from the stop block. Except in our current video with the Z-stuff detectors, we're using a Z-stuff detector here to release the train in front of it. Again, what we call the release from the rear system. Here's the 1992 video, module 5D, demonstrating the APS electric eye. And what you're seeing here is 4 trains being separated by an APS electric eye, which is located over here. And this works very similarly to the Z-stuff DZ-1012 detector with the variable time delay. This APS electric eye had an electric eye in the track rather than an infrared detector like the Z-stuff unit does, but otherwise it worked very similar. It had an adjustable time delay and had one normally open contact and one normally closed contact, so we could use a time delay on this unit to keep these trains separated, which is what you're seeing here now. Here's that same APS electric eye again, the same video showing it operating with a couple of American Flyer S-gauge trains, and you can see it just separated 2 trains that were pushing each other. The detector, in this case, it's an electric eye under the track, is somewhere up here, and when it goes through, it sets a block to red. You can see that light comes on just to the left of my dot, and when that light is on, means the block is in the red state, which means it's depowered, and then it has a time delay, and it'll time out and go to green. But you can see the train going through, set it to red, and stop the one in front of it. Of video 9202 module 5H, which is a copy of the original 1991 demonstration tape that a gentleman named John Aaron, who was marketing this APS-I control, he made this tape And he has a lot of interesting demonstrations on this tape, and we'll play a piece of it here.
So that the locomotive will start ringing its bell before it pulls in, leaves the station, blows the whistle twice as it leaves. The little man comes out of the crossing house, signals are changing. The locomotive keeps its bell ringing from the time it approaches the station until it leaves.
Here we're on the web page of a gentleman named Joseph Rampolla, who has a lot of very useful information for automatic control. This page shows putting reed switches in 3-rail track. Reed switches are another way to automatically control trains. It's actually a little more positive than using time delay like we've been discussing for this Z stuff video, but it does require a little more work. You've got to mount the reed switches in the track, and you've got to put magnets on the bottom of your locos, but nevertheless it's a good way to consider at least doing this. I'm just going to scan down his page and show you some of the information that's here. He's showing the relays here, and he's showing the reed switch here, and here he's just showing some of the wiring for his demonstration layout and other information. And there's a video, a YouTube video that goes with, and he's got a copy of it right here. You can play this, and it shows this system in operation. Here's video 9202 module 4D, and this demonstrates a system using reed switches in the track. In this layout where this green cardboard is, there's a reed switch right here which sets the block to green, which essentially powers up the stop block, which is located over here. And this is like kind of our Z stuff detectors, and our APSI we looked at have a kind of a virtual time delay where we used the time delay in the detector to create the equivalent of a reed switch here. But this is an actual reed switch in this system. Then the stop reed switch is over here. So when a train goes through the block, it passes over the reed switch that sets the block red, turns the power off, so any train following is stopped. We'll take a look at this demo for a minute.
See, the first train went through, set it to red. These other ones are trying to push the next one through. Now the second one set it to red. You can see these two back here. The last one's trying to push the first one through. Now the third one exited and set it to red. Now we're essentially in equilibrium mode for 4 trains. You can see these 4 trains will operate on the track and stay reasonably well spaced.
Here's video 9202 module 6, and in this video we did a simulation of an automatic block, but just using a simple knife switch. Here's a knife switch which we're operating by hand to simulate an automatic block, and the end of the block is right here. Actually the stop block is from here to here, and we have either an imaginary Z stuff detector or an imaginary reed switch that sets the block to red and stops any train following the train that just went through the block. And then over here where this piece of green cardboard is, we have an imaginary reed switch which sets the block back to green, or in the case of a Z stuff detector, it would be about where the time delay ended in the Z stuff detector, changed the block from red to green and turned the power back on in the block. Let's take a look at this demo.
Block is now red. We'll set it to green. This train goes through. We'll open the switch and set it to red. train to stop. Now we'll set it to green and closing the switch, set it to red. I'm just simulating with my hand the same thing the magnetic controls will do. Now it's green, now it's red, that edge went through. Now it's green, now it's red. Now it's green, now it's red. But whenever engine goes through, it turns it off. That's why I set it for red. Now it's green, now it's red. Now it's green, now it's red. Now it's green, now it's red.
Here's the same video, a later spot in the same video. Instead of a knife switch, we're going to just use our hand to simulate an automatic block. And we've actually removed the automatic block from the track. We just have continuous track. Here we've got a piece of red cardboard, which will simulate where the detector would be. This could be either a Z-Stuff DZ-1011 block signal detector, or a reed switch, but some kind of a device that would turn the block off at this place if there were a block. And then over here we've got that same piece of green cardboard, which simulates either a reed switch, it would turn the block back on, or where the time delay on a Z-Stuff detector would end. But you can actually do this on your layout without modifying the track at all, without having put any blocks in the track at all. All you're doing is sticking your hand in the track to simulate a block. Let's take a look at this demo.
Which sometimes happens, but we'll give it a try. The block is now effectively red until that engine crosses the green cardboard. So now the block is green. Now the block is red again, so that train going through it. Now the block is green. Now the block is red, so that engine passing through it. And the block is green. Now the block is red again. Now the block is green. Now the block is red again. Now the block is green. Now the block is red again. Now the block is green. Now the block is red. Now the block is green. Now the block is red.
This is video 664, part 4 of 4. Shows a Railroad Concepts StationMaster in operation. This unit's made mainly for outdoor large scale, but it does work on smaller gauges. Here it's shown on running 2 S-gauge trains. Now this unit operates DC only. However, if you're controlling 3-rail trains, I've been told that almost all 3-rail trains will run fine on DC. And these StationMasters have acceleration and deacceleration built into them. You can program all that stuff. This is a video was made 2011, and the StationMaster has gone through several updates since then. Let's take a look at this video.
Now this train is slowing down and stopping at the block. It'll wait till the second train comes around the loop, goes over the acceleration reed switch, and triggers the block to start.
I've reduced the lights a little bit, so maybe you can see the lights here better. Notice that's green as that train comes into the block. When it triggers a deacceleration center, it goes to flashing red, meaning it's deaccelerating. Now it's waiting. There the second train went over the acceleration sensor over there, and notice it's blinking green meaning accelerating. Now it's solid green, waiting for the train to come in the block, flashing red for deacceleration. Stop and pause. There it goes back to blinking green as soon as that train goes over the acceleration center.
There's video 819. This shows a DCC system in operation just for comparison. We have no blocks in the track with a DCC system. We can do it just using here's a Z-Stuff DZ-1011 detector, and there's a relay behind my hand there, and that signals what is called an NCE mini panel, which is essentially a DCC programmable controller for model trains. In the logic is that there's one train on the main line, which is this train shown here, and then there's two trains in the yard creeping at very slow speed. And what happens is when the train on the main line goes all the way around and passes this detector, the mini panel then speeds up the front train in the yard, and the train that just went around, which will be this Virginian, will come into the yard and it'll start creeping. So let's take a look at that video. There you can see this train on the main line running fast, goes in front of the detector, goes back in the yard and slows down. Now the shark nose is running fast, it goes in the yard, slows down. So basically you're creeping two trains in the yard and cruising one train on the main line. And as I mentioned, the nice thing about this is no blocks in the track at all. You just have this Z-Stuff detector, which tells the mini panel where the trains are. So this is a nice way of controlling trains without having to modify the track, but it does require a DCC system. With the new MTH and the new Lionel trains supposedly being DCC compatible, in theory at least, you could use this NCE mini panel to control O-gauge trains now. One of the videos by TM Books and Video shows some automatic train control operation. If you go to the website Toy Train Revue, and then there's a link over here called Layout Tips. If you click that, that takes you to this page, and if you click on the installing a block system link, that takes you to this page, and it has has a bunch of drawings and stuff. Now that's all illustrated and explained in their video, which is this video, building an O-gauge layout, and that's on, you can currently find that on Amazon Prime, at least in fall 2018, and right around the 20-minute point they start talking and demonstrating automatic block control for about 10 minutes or so. Here's about 30 seconds from that video.
I'm using 3 equally spaced blocks. This will easily accommodate 2 trains with about 6 or 7 cars each. An entire block needs to have the outer rail insulated. The insulated outer rail of a block keeps the relay activated, which prevents another train from entering the block and crashing into the back of the other train. When the first train leaves the block, the relay restores power to the second train, which then safely enters the block.